Welcome to the final episode of 2025. This one covers some of the key highlights and my learnings from the biggest conference I attended in the whole of 2025, which was AWS reInvent, which took place in the first week of December of 2025. So I have compiled a lot of my learnings into a blog, and I will put a link on the next slide. But let's get started with what were the key highlights of this event. So we got into this event with AWS announcing its best quarter since 2022. And in Q3 of 2025, they announced their revenue growth was 20.2%, which is the fastest rate since 2022. So with that, their projected annual run rate is at $132 billion, which is ahead of Azure at 93 billion and Google Cloud at 61 billion. To celebrate this, 65,000 people showed up in person at the typical places where the conference takes place, which is centered around the Venetian Hotel in Las Vegas. And then pretty much most hotels around have some event going on concerning AWS reInvent. I captured all my learnings into a blog, and you see the link down here. It's www.sanchmo.com. If you go here, there's a drop down for blogs, and you can get a copy of my blog from there. So with that, let's look at what were the three top announcements that put AWS in a very different light compared to last few years. And after that, we will go into the agenda. The three big major announcements were multi-cloud, hybrid, and model training. What do we mean by multi-cloud? Anyone who's been to reInvent for many years knows this, that the word multi-cloud could not appear on your collateral or your booth or anything you were presenting inside of AWS reInvent. That was the typically how AWS approached their cloud offering. This year was very different. Multi-cloud was a very important part of the announcement. We will talk more about it. The main announcement in this space was something called AWS Interconnect, which is a secure, high-speed network connection between your Amazon VPC and Google Cloud. That is launching end of 2025. It's in preview right now, and then at some point in time in 2026, we will see an interconnect with Microsoft Azure. But that's just the interconnect. It turns out there were a few other announcements that further enhance AWS's multi-cloud story. So we will get to those in due time, but let me talk about the next big announcement, which was investment in on-premises. This is not a new space for AWS. AWS has had these pizza box sized appliances that you can deploy in offices, restaurants, hospitals. It's called outposts. They also have local zones, they have wavelengths. So there have been a number of compute opportunities for organizations to use their on-premises data. But this time they announced something called AI Factories, which is a dedicated AI infrastructure deployed inside of an organization's network, their own security boundaries, to train and develop AI applications. So more on that when we get to the right section. In the meantime, let's go to the last big announcement, and that pertains to development or training of frontier models on proprietary data. So far, we've been using frontier models from three major companies in the US, and these are OpenAI with ChatGPT, Anthropic with Claude, Google Cloud with Gemini. There are a number of other ones, xAI with Grok, Meta with Llama, although Llama has not been keeping up. And then there are, of course, a vast number of models that came out of China in 2025, starting with DeepSeek early in January of this year, causing quite a commotion in the stock market. But then there's Quen from Alibaba, there's Kimi from Moonshot. So there are a number of these models. AWS also has its own set of models called Nova. There was a new release. We'll talk more about that. But all of these models, they are trained on public data. They don't know anything about your data. You can, of course, use RAG and you can supply your data and then have the LLM work on it. But fine tuning has not really taken off because fine tuning is a very precise art and it requires very deep knowledge of AI and ML. And if you don't have it, then you can fine tune a model and degrade its performance rather than helping you. So with something called Nova Forge, AWS announced an ability to train models on premises using your proprietary data. So with that, let's go into the agenda for today. So we will talk about AI infrastructure as the very first topic, and that will take us to the topic of hybrid multi-cloud. We've already talked about AI factories and interconnect here. AI models, we've talked about Nova Forge, but we will look at what's going on in the space of AI models. No conference can be complete without talking about agents. Agents were a very big part of this year's conferences, every keynote. And these agents are only as good as your data. So we will talk about number of databases, underlying that Amazon storage, S3. And then finally, last year's big announcements were pertaining to SageMaker Lakehouse. This year, we saw a lot of development in its central nervous system, if I may, which is the catalog, SageMaker catalog. So with that, let's get started with the first category, and we will talk about AI infrastructure. Trainium 3 was announced last year at reInvent. In fact, this year, AWS told us Trainium 4 would come when we show up for AWS reInvent 2026. In the meantime, Trainium 3 is now providing 40% better performance, and it's cheaper than NVIDIA GPUs and Google TPUs. By the way, NVIDIA has GPUs. Trainium 3 is not a GPU, it's an application-specific integrated circuit or ASIC. And AWS is calling it an AI accelerator. Last year, we were talking about Trainium for training models and Inferentia for doing model inferences. But it turns out that Trainium is very good at doing both. Over 50% of all models in Amazon's Bedrock, so the token usage is now running on Trainium. If we move to Graviton 5, this is the 5th generation of AWS's ARM-based chip. By the way, both these chips come from an acquisition AWS did a few years ago of a company called Annapurna Labs, and that hardware acquisition has literally been paying dividends. So there's Graviton 5. In fact, over 50% of new AWS CPU capacity in the last 3 years is on Graviton. More than 50% of workloads on things like Redshift, Serverless, Aurora today run on Graviton. There's a new instance type you can see here. It's called EC2 M9G. Also, the 5th generation of Graviton is running on an underlying substrate that we don't talk about too much in our discussions on data and AI, but it's a very crucial part of hardware virtualization. It's called the Nitro card. And this Nitro card ensures that when you have multiple workloads running at the lowest level of the hardware, they're properly virtualized, secured, and the entire storage networking is all taken care of by the Nitro card. On top of infrastructure from AWS itself, there were partnerships galore. In fact, I would say in 2025, we saw as people have been calling the circular investment of different companies investing in different companies. For example, OpenAI has committed to $38 billion of compute over the next 7 years. AWS, in the weeks after AWS reInvent 2025, decided to invest $10 billion into OpenAI, provided they are going to optimize their models to run on Trainium. Talking about Trainium 2 chips, Anthropic is now training their Claude family of models on Trainium 2. They have used 500,000 and they plan to double it. So 1 million Trainium 2 chips are going to be used, or actually Trainium 3 in the future, by the Claude family of models. But while all of this infrastructure buildup is going on, in fact, AWS added 5 gigawatt of capacity by building out new data centers, but the demand is so high for compute that even the mega vendors are not able to keep up. So almost all of them have been signing up partnerships with these third-party compute providers. For example, on this slide, you will see we have something mentioned here called cipher mining. Cipher mining, CoreWeave, Lambda, Iron, these are a number of these different companies that all started in the space of crypto mining. But when crypto mining ran out of steam, many crypto mining data centers actually shut down or were bought out. Like CoreWeave bought out a number of them, and they pivoted to AI. So now they're providing extra compute to AWS, like cipher mining. They're providing 300 megawatts of capacity, and in a deal worth $5.5 billion over 15 years. So that is this is how important AI infrastructure has been in 2025. Let's talk about the next category. This category, we had 3 things listed: multi-cloud, hybrid, and sovereign cloud. I mentioned multi-cloud is being enabled by something called AWS Interconnect, which is this secure connection at high speed. In fact, all the data that goes between AWS and Google Cloud is encrypted by default. Azure will come sometime in 2026. And by the way, this is a space that was pioneered by Oracle. Oracle Cloud is the first one that at scale went and created an interconnect with Microsoft Azure, and then after that they expanded it to AWS and Google Cloud, which is really great news for organizations that may have data in one cloud, but they want to use the AI models and capabilities in a different cloud. Now you have this high-speed interconnect. In case of OCI or Oracle Cloud, we know there's no egress fee. However, for AWS Interconnect, it is still in preview. While it's in preview, there is no charge, but when it goes into GA, then AWS is going to decide its pricing structure. So till then, we have to wait. Interestingly, this is being touted as a great example of customer-centric multi-cloud offering, but as I did my research and I was writing the blog, I realized this is not it. In fact, you see this in, we'll talk more about this catalog federation. By using Iceberg REST catalog API, you can now go to Redshift and be able to see data that is in Iceberg tables, in a Snowflake's account, and you can read and write to it. So there's a catalog federation happening between Snowflake, Databricks, Unity Catalog, and Glue catalog inside of AWS. You also see delta sharing, whereby using an open standard, Redshift can now share its content with any compute that is Iceberg compatible using this open standard called delta share, which came out of Databricks, but now it's becoming pretty much the de facto standard. I'm jumping ahead into various different sections, so we will come back to this later. Let's talk a little bit more about AI factories. An AI factory is different from an outpost. Outpost was more generic compute. AI factory is actually a combination of Trainium AI accelerators and NVIDIA GPUs that can be deployed in an organization's security perimeter. And then it can be used to train models and run AI workloads. The last thing that I also mentioned in this section in my agenda slide was launch of something called the European Sovereign Cloud, so or ESC. So this is to satisfy very high regulatory compliant requirements of European counterparts. So AWS has kicked off this initiative. A new data center is expected to come live, according to AWS, end of 2025, which is just a few days from now, in Brandenburg, Germany. The European Sovereign Cloud is completely independent of the mothership. It is designed, run, managed, governed by European nations, by Europeans, and it complies to all the local compliance regulations in Europe. So this is quite similar. Even a few weeks before AWS reInvent was Microsoft Ignite. Microsoft Ignite also has a Microsoft Sovereign Cloud in Europe that actually it turns out it's better to have a cloud which is run and organized by the local authorities than having to create an extra layer on top. So that is European Sovereign Cloud. With that, we go to the topic of models. When we went to AWS reInvent 2024, last year, we learned about a new set of models. In fact, Andy Jassy, who was previous CEO of AWS, but now CEO of Amazon, he came and announced a family of new models called Nova, which took over from Titan models. So this year, we saw the second generation of Nova models. I've listed a few of these here: Nova Lite, Nova Pro. Each one varies in its capabilities and size. All of them have a capacity of 1 million token context window. Context window has become like RAM. The way we used to buy our PCs and laptops in the past, and we used to see how big is the RAM so I can cache my data in memory. Now it is the same equivalent as context window. So 1 million token is a very large ones. Although there are some models like Gemini has 2 million, but more or less the size of the context window is much smaller for most of the models. A lot of these take images, text as an input, except for Sonic, because Sonic is a speech-to-speech. There's also a new embedding model. And then finally, you see at the bottom is something called an action model, Nova Act. This is quite fascinating to see how this idea of computer use or the browser-based models that automate UI workflows is something that's becoming quite popular. In fact, I've seen some demos where people will say, here are the list of key people that I follow in X. Go to read through my list, go to each one's latest tweet, and then respond to it accordingly. And you can sit back and see these models opening up windows, they're writing the content, they're sending it, and then moving on to the next area. So that is what's new with Nova 2 models. I have some more details in the blog if you are interested. As I've already mentioned, Nova Forge to me was the most interesting thing. And the reason for that is because RAG is a great approach when I want to query something, retrieve it from my database, and then send it to an LLM. But what if I don't know what exactly is my query, and I don't want to go through this multiple step process? In that case, I want my model out of the box to be trained on my content. Reddit is a great example of that. Reddit is using Nova Forge because it has so much of content of its own in its subreddits that it can train the whole model based on its own proprietary content. So this idea of pre-training a model with proprietary content used to was actually very difficult to do, and if somebody did it, it would really be, the cost would be in millions. And now what AWS announced was that using an offering called EC2 Trainium 3 Ultra servers, which is a box with 144 Trainium 3 servers, organizations can train their own models at $100,000 a year. So that takes us to the next section. And here we are going to talk about agents. Agents, as I said earlier, were all over the map. Every product today has its own agent. So there are two things we'll talk about here: agents that already exist in different products, and then something called frontier agents that you see on this slide. So here are some examples of agents that I saw in action. I walked over to the Expo show hall, and I was at AWS Marketplace. They were demonstrating the agent mode. AWS Marketplace has grown to now over 30,000 products. But you still have to go and find the right product that meets your needs. What agent mode does is it allows you to ask the marketplace in natural language for what product you are looking for. For example, let's say I'm looking for a streaming platform based on Kafka or Flink. There are literally dozens of them, from Confluent, from Red Panda, Rising Wave, a whole slew of companies now have Ivan. There's so many of them. So how do I know which is the right streaming platform for me? This is where the marketplace agent kicks into action, because not only is it able to find the right product based on my request in natural language, it also does a comparison of the products it found based on some criteria which I may have defined in my natural language. Now it helped me decide which is the right streaming platform for my need. Next, I click a button and it creates me a proposal. All of this is done within seconds. And I have a proposal now for the streaming platform that I want to deploy. So as you can see, AWS Marketplace is no longer just a product-oriented service, it's more of a solution-oriented service. Same thing, you see agents inside databases, you see agents inside modernization service. For example, there's an agent called AWS Transform Custom that can look at your code base. If it finds that some code base is in, let's say, Python 3.8, which is reaching end of life, then it can help you modernize it to a newer version of Python. Those are the product-specific agents. On top of that, AWS also launched a set of 3, what they call as frontier agents. These frontier agents are defined as autonomous, which all agents must be, otherwise they should not be called an agent, massively scalable, and and they're designed to work for hours or even days without any human intervention. Take an example of the first one. It's called Kiro Autonomous Agent. Kiro, as many of you know, is Amazon AWS's IDE for agentic development. A lot of AWS developers when I interacted with them, they spoke very highly of this product because it is something that's slightly different from cursors and replets of the world, in the sense that when you give a natural language prompt as to what your requirement is, Kiro first develops your product requirements document, or your PRD. So it's a specification based development environment. It then writes the code based on the PRD, and it's very interactive because it also creates unit test cases, tests against them, and it keeps the PRD up to date. So what is the purpose of a Kiro autonomous agent? This agent is meant to work in cases where, let's say on a project, there are multiple developers. But these developers are in different geographic regions. They have their own repositories, and they're running a very complex set of tasks, but they need to collaborate. When you need to collaborate, you need the agent to maintain the state, the context, the memory, and that is what Kiro Autonomous Agent does. So it's able to coordinate work across multiple developers with multiple repositories who are collaborating with each other. The next thing it does in this life cycle is it kicks off an AWS security agent. This security agent is going through the code as it is being developed, and it is doing reviews, it is finding security loopholes, it's fixing them, and even doing penetration test. When you're ready to deploy your new code into production, you need observability, you need a lot of DevOps. That's where AWS DevOps agent kicks in. It helps do root cause analysis very quickly, tries to triage where a problem took place and fix it. So the whole idea of these frontier agents is to be able for developers to deploy their solutions as quickly as possible. That takes us to the second part of agent development. So the first part is what agents have been launched, but how do you develop these agents well? Every vendor, every event I went to this year, I saw mega vendors had their own, some agent development kit or some methodology to develop agents. AWS has its own. It's called Agent Core. What differentiates an organization's agent development methodology from another is how well and how well thought out is the process. So in case of Agent Core, when we were at the day 2 keynote by Swami, he talked about how the fine-grained policies can now be applied across the agents. These fine-grained policies can be written in natural language, or AWS has open sourced a language called Cedar. Evaluators are now included. Evaluators are extremely important because these models are probabilistic, so they will behave differently even if the data has not changed. So you need constant evaluation of the outcomes of a model. In fact, this is how agentic development differs from software development. In software development, you get deterministic output. The output does not change. But in case of AI, you need constant evaluations, and also you need to maintain episodic memory of what is going on during the development process. Model context protocol was also everywhere. What I was quite impressed to see about MCP is, although MCP is a very new protocol for agents to call tools, but now Anthropic has given the code and the management of MCP to the Linux Foundation. The Linux Foundation has launched a new foundation within its governance called Agentic AI Foundation that is responsible for upkeep and further development of MCP in an open source, vendor neutral manner. By the way, the Agentic AI Foundation also has now received a new product. This one comes from OpenAI, and this is a file. It's called agents.md. This is like the README for agents. So when you have multi-agent, agent-to-agent development going on, how does one agent know what the other agent does? That information is in agents.md. OpenAI created it. It's now widely used. It is also part of this new foundation under the Linux Foundation. We have one more announcement about the Linux Foundation, and we will talk about it when we talk about the third piece here in the databases. So let's talk about what were some of the core database announcements. This year, 2025 reInvent was not a strategic year for database announcements. Last year, I mentioned already SageMaker Lakehouse was a center of attraction. This year, it was about AI, infrastructure, models, and agents. In the last few minutes of AWS CEO Matt Garman's keynote, he highlighted one announcement, and that one has to do with something called the Database Savings Plan. What is Database Savings Plan? To understand that, let's go understand how is pricing done in the cloud. You can pay per use or pay as you go, which is also the on demand. So if you have very spiky loads, your cost may actually go up quite a bit, but you pay as you use the service. If you cannot live with this unpredictable spiky cost, then a lot of organizations reserve capacity. These reserved instances are for 1 year or 3 years, and you basically reserve certain amount to be used. If you don't use it, you lose it. And so it requires a lot of management of reserved capacity. Savings plan is for steady state workloads. It's a much cheaper option. In 2019, AWS introduced EC2 Compute Savings Plan. After that, according to Matt Garman, the number one requested feature was a similar savings plan, but for databases. So that got announced in 2025. What is it? What it means is that this whole management of reserved capacity goes away. Also, let's say you have an environment where you've got RDS, Aurora, Elasticsearch, DynamoDB, and you have a number of different offerings. All of these offerings have their own reserved instance. But a database savings plan not only gives you higher discounts, but it's also one common pool, if you may, of any operational database. So today, if I use RDS, but I decide to go to Aurora Postgres, I don't need a new reserved instance kind of a savings plan. It's database savings plan already has it built. If I change instance type, if I go from provision to serverless, it's the same savings plan. What do I get? 20% discount for provision, 35% discount for serverless. There's some variations depending upon which database it is. Today, by the way, your database has to be on either generation 7 or 8 of instance type. And it's mostly for operational databases and database management service, migration service, DMS. So it's not for Redshift or some of the analytical as yet. The important thing here to note is that there's higher discount for serverless, 35%. And that's because AWS would like us users to not have to worry about what is the instance type, did I pick the right instance, but use a serverless. So by giving higher discount for serverless, AWS aims to get more people to use serverless options rather than than provision. Next announcement is on the distributed SQL Postgres from Aurora. This one was announced last year at reInvent. It went GA earlier this year. But we just talked about how important serverless is. Aurora DSQL was built from ground up. It's not the same code as Aurora database for PostgreSQL, by the way, because of the way distribution of jobs takes place across regions, zones, and regions. We see it does not have serverless. It does not have vector data types as yet, even foreign keys. So that's a second announcement. The third one has to do with Amazon's OpenSearch service. In 2021, Elasticsearch changed its license from being open source to being what's called SSPL. And with that led to a fork of Elasticsearch into something called OpenSearch. This is the third announcement of the Linux Foundation that I was going to talk about. The third product is OpenSearch. There's a new foundation that was created for this called OpenSearch Foundation. So the big things here are GPU indexing, which is at one quarter the cost, 10 times the speed. And OpenSearch is now using something called S3 vectors, which we will talk about in a few minutes. There were many other announcements, such as a very optimized way for how the KNN indexes are chosen. And so there were a lot of optimizations in OpenSearch. A number of other announcements took place here, like dynamic masking in Aurora Postgres, but we will keep that for a different time, and we will move on to the analytical side. So on the analytical side, there was a lot of focus on SageMaker Catalog. SageMaker Catalog is a superset of 3 different catalogs. Glue, which has been around for a long time, but it's for technical metadata. Data Zone, which was introduced a few years ago, is for business metadata or the semantics. Although AWS did not spend a lot of time talking about semantics, like Snowflake with their open semantic interchange, or Databricks with their Unity catalog metrics. We didn't hear too much, but the pieces are there in Data Zone. And next year at AWS, we think we will hear more about semantics. And then the third piece that makes up SageMaker Catalog is the lake formation catalog, where all the permissions, so row level, column level security, masking, all of that, those policies get enabled in lake formation. SageMaker Catalog also is Iceberg REST compatible API, which means that now external data in Snowflake and Databricks can be visible in SageMaker Catalog, and vice versa. So this is a bi-directional piece. The overarching piece that sits on SageMaker Lakehouse is called SageMaker Unified Studio. It is sort of the single pane of glass place or single interface for you to run any of your ETL, your machine learning, your AI workloads, all through the SageMaker Unified Studio. If you have proper permissions in place, then it's one-click onboarding of these external catalogs now onto SageMaker Lakehouse. On the Redshift side, there were a number of other enhancements. Security policies used to be defined in Redshift. Now you can define them in SageMaker Catalog, and Redshift can read it straight from there. We already talked about Delta Share becoming the open standard for sharing Iceberg files. Even materialized views that used to sit inside Iceberg, inside Redshift managed storage, these materialized views could be sitting in Iceberg. on Amazon S3. So here are some examples. We've talked about most of these things, so I'm going to skip this. There were so many other announcements, such as there is a built-in notebook now inside SageMaker. It used to be that you could use Jupyter, and you still can, but if you have code written in Jupyter and you want to run it, a Python code, you need the Jupyter engine. With this web-based SageMaker notebook, now you can have one place where you can intersperse SQL code, Python code, all together in one place. So this is something that developers also like, and it is, by the way, Jupyter compatible. Another piece that also got mentioned that you don't see here on this slide because of space is this idea of notebook of Apache Airflow serverless. It used to be that because there are a number of different tasks that are taking place inside SageMaker Lakehouse, you could orchestrate them using the managed Apache Airflow service inside AWS, but you had to set up that Airflow cluster manually. Now all that is automated. So it's become more serverless. You can still orchestrate using Airflow, but you don't have to stand up your independent cluster. That takes us to the last piece that we're going to talk about here is on Amazon S3 and S3 tables, S3 vectors. This is sort of the workhorse of AWS. When S3 first came out in 2006, so it's coming up to its 20th birthday, like the rest of beginning of AWS. At that time, it was more of a storage. There was a limit of 5 terabyte for file size. This year, that limit went to 50 terabytes from 5 terabytes. And the idea is that now you've got your images, your videos, and you basically have a Nova 2 embedding model. It can read the videos, it can create a table with all the embeddings. So larger objects have become really important. S3 has also become very performant. In fact, some of the offerings now require 100 millisecond response time, which was unheard of in S3. As an example, there's a well-known time series database called InfluxDB. InfluxDB, in its original iteration, was completely based on a data structure called LSM tree, or log structured merge tree, because it needs to be able to get very high speed writes into the database. The developer of InfluxDB rewrote the entire database, first of all using Rust as a programming language, but on top of S3. This service is now sold as something called Amazon Time Stream for InfluxDB. So it's all in S3. A huge announcement last year was called S3 Tables. Now, S3 Tables is managed Iceberg. What happens in Iceberg is that when you have a lot of streaming data coming in, we end up getting a lot of Parquet files, and then the metadata has to be maintained. The manifest file has millions of these files that are getting created. It slows down the queries. There's a lot of management overhead. So it's very important to compact these files, small files, into a larger, more compact version. This task is costly, and most Iceberg tools will do it. So what AWS announced was S3 Tables, which is managed Iceberg. So if they're redundant files, the orphan files, compaction, a lot of this management overhead is now handled directly by S3 Tables. So S3 Tables have a lot of now very interesting problems that we used to deal with in normal files. For example, we used to create copies of a database, read-only copies or replication, so I could run my queries faster. Now, replicating an iceberg table is not easy because there are all these metadata dependencies on the underlying Parquet files. So this year we saw that S3 tables now has automatic replication. Intelligent tiering was introduced for files that are not that frequently used, so you can intelligently move them into a cheaper type of S3 storage class. That is now also enabled, that intelligent tiering is now enabled for S3 tables. In fact, one of the biggest announcements was at S3 now, you can store the vector embeddings. In fact, 40 billion vectors are already getting stored on S3. So your options are you can either use a specialized vector database, or you can use a traditional DBMS, either relational or NoSQL, with vector as a native data type. What AWS is saying is that you can actually use S3 as your vector store at only 10% the cost of a normal vector database. And this S3 vectors is being used by even OpenSearch. Another thing that's also using, we didn't talk too much about Amazon Bedrock in this discussion, was there is something called Amazon Bedrock Knowledge Bases. This is a service that is used for RAG, when you have to retrieve some data and then send it to an LLM. Even knowledge bases, you can now specify and say, use S3 vectors as your storage, your source for vectors. And so you can see that S3 vectors, although they are new and they are now GA, there is a lot of future uses of S3 vectors. So with that, we will end our discussion here. Thank you so much for your time and for sitting through till the very end. Until 2026, it's been a pleasure talking to you every week or every few weeks, and we will start afresh next year. Thank you so much, and all the best. Happy New Year.